Hello everyone. So in this assignment part 2, I built a deep learning regression model using the TensorFlow and Keras to predict vehicle flow efficiency measured in miles per gallon. First, I prepared the dataset and separated the input features from the target variables, which is miles per gallon (mpg). Then I split the data set into training and validation set so that the model could train on one portion and evaluate on other on same data. So this part I was just uploading the data, and I was trying to figure out if I uploaded successfully, and I also print the data head so I can take a look at the first 5 rows. Okay, and then based on the requirement, I was just checking the missing values and convert the year numbers to the actual year numbers, like in 70 or 40, something like that. Okay, and after the processing, I construct a neural network using the Keras model sequential. The model contains 2 hidden layers created with the Keras layer stance. Each hidden layer has 64 neurons, and they use the ReLU activation function to introduce the non-linearity. The final output layer is defined as dense 1 because it's a regression problem predicting a single continuous value. Yeah, and this part was advised from AI, from GPT and DeepSeek. And then I compiled the model using the data compile, specifying the item optimizer for weight update as a loose function to minimize prediction error, and aiming as the additional evaluation matrix. So basically, as I just scrolled, there are 200 applicants with the bench size of 32. And during the training, I include the validation data so that the both training and the validation performance could be monitored. And after training, I evaluate the model using the model evaluate on validation set to calculate the average prediction error. Finally, I use the model predictor to generate miles per gallon predictions for new vehicle input, ensure that the same scalar transformation was applied before prediction. And still, because I tried many times, the previous result was around like a 2000 something. So it's like a so I realized that there must be something wrong. So I start from the very beginning and I tried many times. And this is the result I advise from my friends, my classmate from GPT, and eventually I have this predicted numbers. Still, I think it's quite unreasonable, but based on the information, the input, I think it is possible, because when we input this data, it's not something that in our real life. That to say that the prediction is not based on our real life. So I would just simply to show the result. So I was seeing like the result of showing the model perform like reasonably with the training data range, but one new input for outside of the original distribution, the prediction become unrealistic. This demonstrates the limitations of neural network in actual exploring BR0 training data, and overall the notebook demonstrates the complete pipeline of processing, model construction, training, evaluation, and prediction using a deep neural network regression model. And some part of the coding was otherwise from GPT. And after I did that, I still like not sure like if I'm doing it right or wrong, and I was trying to figure out other values and double check if I got something wrong with the years, because initially I was ending like a 19,000 to make this the actual year to get a range. So I was just double check if I was doing that properly. And although the result is not not realistic, but still in this assignment I've just built a deep neural network model to predict the fluid consumptions by using the provided data set. The model learned relationship between the features like displacement, horsepower, weight, and year. And when I tested the model on new vehicles, I noticed some predictions was unusually high. I think this is because some of the test vehicle had features value outside the original training range, especially in a displacement and the year using 1970s data to predict a 2035 miles per gallon, and the placement was given on assignments on Euro high. Especially you see those one over 6,000, and even the horsepower is incredible. This one is extremely high, which is making it impossible in our real life, I would say. Yeah, from here, this is directly copied from the assignment requirement. As I mentioned, since the data we feed is unreasonable, so the result could be unpredictable as well. And I think it's important to limit the machine learning model as they can perform better. One new input follows the same distributions as the training data. We can't it's more we're giving some informations based on 100 years ago, and then asking the machine to predict what's gonna happen in 100 years after. If we can be more asking for the closer date, I think the accuracy could increase. Thank you.